So this is a review of the new Phoenix Engineering LLC PSU power supply unit for AC Synchronous motors, turntable motors, and the accompanying tachometer box, which they call the Roadrunner. I just bought both, and I've hooked them up to my VPI Scout turntable. I have everything, I think, attached and calibrated properly, and I've put a record on the platter to kind of simulate listening conditions, and so we're going to take a look at how this thing works. To get started, I wanted to just comment on the quality of the packaging and boxing for this this upstart kind of cottage industry company, Phoenix Engineering. I ordered both the Roadrunner and the Falcon PSU together, and they both came in identical boxes, but they have well done labels on them that are kind of indicative of what you'd see from a regular audio company. The manuals are well done. They're short, but they're very clear, concise, give great instructions. There are also online manuals which were posted up on YouTube, and they are excellent. I watched the longer of the two, which goes over both of these units, and really covers all the features and operating instructions of both units in a very clear and concise way, which is really appreciated. The box and the packaging really is top-notch for this kind of a, again, for this type of an offering. You just don't expect this. You can see the cutouts in the foam. Nice heavy-duty foam was used. Everything was very well laid out in the box. Very impressive. Pricing on these units, the Roadrunner is about $235, and the PSU is about $379. So before shipping, they ring in at a total of $614 for the pair, and that includes all the cables and power connections and so forth. So if you compare that to the SDS at more than $1,300, these are really quite the bargain, assuming that they work. So let's get down to seeing how these devices work. Here's what I'm going to try to do for this video. What I did is I hooked up both units from a power standpoint. But the first thing I'm going to do is spin the table with just the tachometer on it, just to get a baseline of where the table is to begin with. I was kind of interested to see, how badly off is the VPI to begin with, and is it even worth having one of these things? So I hooked it up. It's not hooked up to the power supply. The turntable's just normal, hooked up the normal way. The motor's hooked up to my power supply, but not to the PSU. And the Roadrunner is hooked up with a sensor. There's a magnet sensor that attaches to the bottom of the platter, and it basically there's another sensor which attaches to the plinth, and the magnet, when it passes over the sensor, gives the tachometer a reading, and that basically it takes 2 spins to start reading, and it automatically will turn on. So what I'm going to do is I'm going to turn this on now. Focus on it. So it'll take a couple spins, you get the lines, and every time you get that dash you get a reading. So this is on startup. You can see we've got some big fluctuations, which I guess is not all that abnormal on one of these. So now my table, you can see, is reading quite high, 33.6. We saw some 33.7s. It's starting to settle down now in the 33.6s. Now, one thing I wanted to tell you is the VPI at least has an adjustable, the Scout at least has an adjustable, it's like a gimbaled spindle where you can adjust the belt for different speeds. So I'm going to adjust that up a little bit, and you'll see that this speed goes down quite considerably. I never realized that had such a big effect, but it does. So now I'm just going to lower it a little bit. See if I can approximate 33.3. There we go. There we got a 33.3 reading. It's not perfect, but it's close. So it looks like, there we go. That's about the best we're going to do, it looks like. So that's what we're getting now. So the next thing I'm going to do is I'm going to hook up the power supply unit and not connect the tachometer. When these two units are used in conjunction, the tachometer will actually use its reading to automatically adjust the speed controller, which makes it very handy. But what I'm going to do first is not connect the two so we can see what just what the effect of the power supply is on the rotation. Okay, so now I have the VPI motor connected to the Falcon PSU, and as you can, I have the motor on. You can see the platter is not spinning because I have not switched it on. You switch it on with this. There's a button, standby button, and it should be preset to 33.3. So I just fired it up. We have rotation. The bracketing of the numbers seems to be much tighter. 3391, 3390. Okay, and now so I have everything connected. I've got the Roadrunner hooked up, and I've got the Falcon connected to the motor, and the Roadrunner and the Falcon are connected with the supplied cord, which will enable the Falcon to use the readings from the Roadrunner to help stabilize its speed in real time. So we're going to switch on the turntable. See the target speed of 33.3. The turntable is spinning. And then we'll see what readings show up on the Roadrunner. I have noticed that during the afternoon that the speeds on the Roadrunner became more and more towards a goal of 33.333 all the way across. You know, the longer it ran, the more consistently it stayed. You can see even now we've got 33.33, and just the thousandth position keeps changing a little bit. But overall, very stable. The sound has been great. You know, I can't honestly say that it's a night and day difference, although I was playing around with the speeds a little bit, and pretty small fluctuations in speed. When I intentionally dialed in different speeds, you could definitely hear the differences both low and high when you change the speed on the PSU. So you know, and unlike unintentional pitch variance, you know, when I was adjusting the pitch, I was adjusting it for a constant speed, either higher or lower, and the PSU and the Roadrunner would work to keep it on that particular speed. So you know, it would sound a little bit faster, a little bit slower, but you know, stable in either way. You know, when it's you know, without these types of units, if the speed is fluctuating to those extremes, you could see the effect it has on the music. So as you can see, we're getting a reading, really consistent readings here of 33.333, 332, 334. So overall, very impressive. So all in all, I'm pretty impressed with the two devices from Phoenix Engineering, the Falcon PSU and the Roadrunner. They seem to work as they are intended to work. They're very easy to set up. They appear to be well made. They have kind of an industrial quality feel to them. The buttons and the you know, the cases and the packaging, everything, you know, everything about them all seems to be a very high quality. As you can see from this continuous, as I continue to run this thing, it's very, very stable, and it achieves a couple of important functions. I think that it's really invaluable to have a running tachometer function on your turntable to show how fast it's turning. As I said earlier, I think I always knew that the gimbaled spindle was good for some variation in speed, but I never really knew what that variation was, or where I was really running it. I kind of relied on my ears to tell me what sounded good, now I could see exactly how much variance is built in there. And sometimes when I switch between 45 and 33, I don't really pay much attention as to where the belt goes on the spindle. Now I can see how important that is. So at a very minimum, the Roadrunner seems to be a no-brainer at, it's $200 and some odd dollars on eBay. It's a very good buy. The PSU also seems to be a great companion piece to it. You can see the stability that it's able to generate, especially used in conjunction with the tachometer. And the other thing is it's a fraction of the price of the VPI branded unit that does only part of this function. The VPI will do the speed stability. I guess you could argue which one does that particular function better. And there are two different technologies, neither of which I understand from an engineering standpoint. But it does not have any ability in itself to monitor the speed of the turntable and make adjustments. It relies on the input that you put into it. So you have to use a strobe or other speed sensing device to give the SDS the information it needs to for you to set it. This is completely all on its own. When you hook these two units together and put the sensor on your turntable, you plug it in and the machines do all the work. So it's kind of neat. Also, as time goes on and things do wear out, bearings may become less lubricated, or after long hours of use, maybe the lubrication changes, or over time the belt tension changes. This will continually monitor that and make changes. So it's pretty cool. I have to recommend it. Nice piece, nice job by Phoenix Engineering. Thanks for watching this video.